Okay, so these are tension problems, and in each of these problems, the object is at rest. So the first thing you need to do is draw your forces into your free body diagram. So we are always going to look at the point that is at the center that has all the forces acting on it. So in this question, the point is right here at this Y. But we also have this other object down here that has both weight and tension, and it is also not moving. So you can see that T3 has to be equal to mg down, which is 200 newtons, because this block is not moving and the only force keeping it up is T3. So that's going to help us. Again, we have forces at angles, so we know we need to split them into x's and y's. And so you're going to draw your axes back in. You can see that this angle is the same as this angle, and this one is the same as here. And so now we're just going to do the sum of the forces in the x. So we have T1 in the x direction, and we have T2 in the x direction, and that's it. And then we can plug in our trig here. So T2 times the cosine of 50 will be equal to T1 times the cosine of 70. But now we have two unknowns, and so we have to move over to the y equations. So we have T1y plus T2y minus T3 equals 0. And we can plug in our trig here, so T1 times the sine of 70 plus T2 times the sine of 50 minus T3, which we found was 200, equals 0. But again, we still have two unknowns. So just like in math, when you have two unknowns in one equation and two unknowns in another equation, what we're going to do is solve for one of these unknowns. So let's solve for T2. So T2 is equal to T1 times the cosine of 70, which I'm going to plug in my calculator, divided by the cosine of 50. So this comes out to be 0.532. Make sure you're in degrees. And now what you can do with this is plug this in for T2 over here. This is called solving simultaneous equations, and you do it in math all the time. And now you can plug into your calculator a few things. So, for example, 0.532 times the sine of 50 is 0.408. And I can plug in the sine of 70, and that gives me 0.940. And now I can add my T1s together. This is like 1x plus 2x. So you can add 0.940 and 0.408, and you get 1.35 T1 minus 200 equals 0. And now you can solve for T1. So 1.35 T1 equals 200. Divide both sides by 1.35. And you get T1 equals 148 newtons. Now to find T2, you just plug it back in up here. And you get T2 equals 78.8 newtons. So we found T2, we found T3, and we found T1. So a little bit trickier math, solving simultaneous equations, but it's the same thing that you do in math class all the time.